number of you seem to be struggling with normal distributions. So I have some additional problems. I'm going to try to work through them in Minitab specifically because some of you seem to be struggling with those particular commands. But a couple of things before we start. When you're working with a normal distribution, whether you're doing problems where you're asked to find the probability or whether you're doing problems that ask you to find a particular X value or a cutoff score, you have to know three things. Okay? The three things that you have to know in order to work a normal distribution problem is you have to first know that you are dealing with a normal distribution. And typically somewhere in the scenario, as you're reading it, you may see the phrase normally distributed, or it could say is distributed normally. Again, the verbiage, it could change from scenario to scenario, but you have to know that you're dealing with a normal distribution. That's also a big plus for you because you know that you're dealing with a normal distribution, which then hopefully will take you to or help you to recall this particular process that we're going to focus on here in just a minute. Secondly, in order to work the problem that involves the normal distribution, you have to know the population mean, which is represented by the Greek letter mu, and that is typically, again, stated in the scenario. So it's given. Okay, so that information has to also be given. And the third piece that you need is the population standard deviation, which is the Greek letter sigma. And again, that is actually also stated in the scenario. So you are given the three pieces of extremely vital information for working a normal distribution in the scenario. And oftentimes it may be the first sentence or the second sentence. Towards the end of the scenario, then, I guess really the fourth piece of information you have to have is the question itself. You know, what is it you're looking for? And it's worded in one of two ways. You're either going to be asked to find the probability. It might not necessarily be the word probability. They could also say find the percentage. The difference in the words is how they want the answer expressed. The other one would be to find the X value. It might say find the cutoff score. Again, it just depends on who writes the question or how the researcher states it. So you have to know those three things. I've included here the steps for Minitab. Now I'm going to demonstrate those, but I have them listed here at the beginning of this document, and I'll post it into D2L so you'll have access to it. Okay, so I'm going to scroll on down to the questions. Okay, so the first question says, using this information from the National Health Survey, and I'm going to make this print a little bit bigger. It tells us men's heights are normally distributed. See, very clearly it tells us that we're dealing with a normal distribution with a mean of 69 inches and a standard deviation of 2.8 inches. It also tells us that women's heights are normally distributed, again very clearly, with a mean of 63.6 inches and a standard deviation of 2.5 inches. Okay, so we're going to use this information. In question 1, it says the standard doorway height is 80 inches. What percentage of men are too tall? That is, their height is greater than 80 inches to fit through a standard doorway without bending. Now, I personally like to draw a sketch of what it is that I am looking for. Okay, so I know that men's heights are normally distributed. So I'm going to have my horizontal axis and my bell-shaped normal distribution, and the mean is in the middle. And for men's heights, it tells me that the mean is 69 inches. So I'm going to put that in the center, and that becomes my point of reference. I'm looking for, the question says, what percentage of men are too tall? Okay, meaning they're greater than 80 inches. So if you want to see that written in symbols, we're looking for the probability that a man's height is greater than 80 inches. So if I think about my picture, 69 is the average or the mean, it is in the middle, and 80 would be somewhere to the right. Here's 80. Think about a basic number line. 80 is bigger than 69, that's why it's on the right hand side. And I want to be greater than that, so I'm to the right, this shaded area. So I'm looking for the probability of this shaded area. And it's such an odd shaped area, I can't just, do like area is length times width or whatever. We could do calculus. We prefer not to. Okay? So a couple of things I'm going to make note of here. One is, because this is greater than, and if I look at my picture, my area that is shaded, this would be considered a right tail. Okay, because I'm shaded to the right because it is greater than. That's going to be important to me a little bit later on. The other clue that I have here is that I'm looking for the percentage, or I'm trying to find the probability. So when I go to the Minitab command, I have to determine how the shaded area is defined. Because I'm looking for the probability, this shaded area was defined by the given value of 80. So it is defined by the x value. Okay, so I need to take all of this information, and I'm going to go out to Minitab to put the question into the program to get the answer. Okay, we go to the top menu bar to graph. On the drop-down menu, we choose probability distribution plot. The wizard appears on the screen, and I want to view probability. So I'm going to arrow to the right and highlight in black view probability, and I'm going to choose OK. On the next screen, I have to tell it what type distribution I have. It was clearly identified. Men's heights are normally distributed, so I have a normal distribution. The mean was 69. It told us that. Go back. Mean of 69 for men's height and a standard deviation of 2.8. So I enter the mean that was given as 69, the standard deviation of 2.8. I'm not finished. I have to click on the other tab labeled Shaded Area. We decided that my shaded area is defined by the x value. It was a right tail, and my x value was 80. We wanted to know what percentage of men is greater than 80. And then I click OK. And in this top window, my answer appears. My answer is this small decimal number. It's such a small number you can't hardly see it on the graph, but it's 0.0000427. Okay, so I'm going to write that decimal number now. Based on what Minitab tells me, this shaded area in decimal form is 0.0000427. Now that's a decimal. We were asked for a percentage. To get a percentage, we multiply by 100%. So I'm going to multiply this decimal by 100%, which gives me 0.00427%. Basically, you're at, 400ths of a percent of men are too tall to fit through a standard 80-inch doorway. All right, moving on to question 2. Question 2 asks, what percentage of women are too tall? And again, that's if they're greater than 80 inches to fit through a standard doorway without bending. Okay, so it's the same type question, but our focus has shifted to the women. Okay, so we still know that women's heights are normally distributed. So you have your horizontal axis, your normal bell-shaped symmetric curve with the mean in the middle, and the mean of women's heights, we were told, is 63.6. Again, I'm looking for the probability that a woman's height is greater than 80 inches. Again, thinking about that in terms of my graph, again, 80 is definitely higher than 63.6, and I want to be greater than that, and greater than would be to the right of 80. That's where I would find numbers greater than 80. So again, this graph is right tail because I am looking for the percentage or the probability. Okay, again, that gives me the clue that I'm going to find the shaded area is defined by the x value. Again, we were given the x value. So again, we go out to Minitab. Let me double check about what our mean is 63.6 and standard deviation is 2.5. So we go out to Minitab, we start over. Go to the top menu bar, graph. On the drop-down menu, we choose probability distribution plot. We arrow to the right to highlight view probability. We click OK. We have a normal distribution. The mean was given as 63.6 and the standard deviation was 2.5. I click on the shaded area tab. My area was defined by the x value. Again, it's a right tail and my value is 80. I click OK. And again, I get this graph, and this looks really funky when you look at it because it's 2.6904 e to the negative 11. It is such an extremely small number that Minitab has converted it to scientific notation. So let me go back here because I don't remember what it was. 2.6904. 2.6904. It says e to the negative 11. That means times 10 to the negative 11. Okay, which means if you wrote that number out, you would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 decimal places. You have 10 zeros, and then you have the number 26904. For all intents and purposes, that value is 0, guys. But this would be the decimal. Again, if you change that to a percentage, which is the value you're asked for, you're going to multiply by 100%, which would give you 0.00000002694%. As I say, for all intents and purposes, all women will fit through a standard 80-inch door. And then question C there asks you to basically kind of think about what that means. Does it appear the current doorway design is adequate? I would say yes, because we've just seen that basically all women are going to fit, and all men except 0.04% are going to fit. So I would say yes, it is adequate because the majority of men and women are going to fit through that standard door. So then letter D, still talking about height, says if Miss Ralston designs a house so that all the doorways have heights that are sufficient for all men except the tallest 5%, what doorway height would be used? Is it possible that I could design a house where the doorways are maybe shorter to hopefully save some money on the wood that would be required? So here again, this question is a little bit different, but we're talking about men, okay? And we know from above that the men's heights are normally distributed with a mean of 69 inches. And we want to redesign the door so that it will fit all the men except the tallest 5%. Okay, now you got to think about this. This question gives you a percentage. It's not asking you to find a percentage. Okay, so this tallest 5%, on this grid or on your graph, remember we would start at 0% on the left and work our way up to 100%. If you're thinking about short to tall, okay, remember the mean is in the middle. So short people would be on the left, so it does work short to tall. And we want to exclude the tallest 5%. Okay, so tall is on the left, so I want to cut off these men that are up here that are the tallest 5%. I want to exclude these men. And what I'm looking for here is the corresponding X value. It says what doorway height should be used. So I'm looking for this X value. What does that correspond to? Okay? You got to be careful, guys. You got to pay attention to the wording and know whether it's on the right or the left. Again, this one, because we're cutting off the top half, this would be considered a right tail. But because we're given that percentage, Our shaded area is defined by a probability. I'm actually looking for the corresponding x value. Okay, so you have to pay attention. Everything you need is given in the problem, but you have to read it. You got to slow down. Okay, for the most part, the Minitab works the same way with a few different selections. Okay, so we go back out to Minitab. We go to the top menu bar to graph, probability distribution plot, arrow to the right to highlight view probability. I click OK. Again, we have a normal distribution with a mean of 69 inches for the men and a standard deviation of 2.8. Then for my shaded area, this time my shaded area is defined by probability. It is a right tail and it's 5%. You do have to change 5% to a decimal. And I click OK. And guys, if you'll notice, this picture here in Minitab looks similar to the one that I drew on the paper, and it's 73.61. We're looking for this x value here on the bottom of the horizontal axis that's labeled x, 73.61. So my x value here is 73.61 inches. So I could redesign the doors in my house so that they're only 73.6 inches, or maybe round up and do 74 inches, and I would still be able to fit all the men except the tallest 5%. Okay, let's move on to a different question here. Okay, different scenario completely. It says business. Let me make this one bigger if I can. Sometimes it won't let me. Oops. Let me tell it to stop drawing. And it's not going to let me. All right, so it says monthly mortgage payments. The average monthly mortgage payment, including principal and interest, is $982. Okay, so it says average monthly mortgage payment is $982 with a standard deviation of approximately 180. Assume the mortgage payments are normally distributed. Find the probability that a randomly selected monthly payment is more than $1,000. So here again, in the scenario, you're told that the average monthly mortgage payments are normally, or the monthly mortgage payments are normally distributed. The average is 982 and the standard deviation is 180. You have to know those three things. And then this one says find the probability. Okay, the fact that it's asking me to find the probability leads me to the fact that my shaded area for Minitab is defined by an x value. Okay, when the question says find the probability, your shaded area is defined by an x value. And again, I like to draw a picture. So I have my horizontal axis, my normal bell-shaped curve, the mean is in the middle, and the mean, I'm told, is $982. And I'm looking for the probability that my monthly mortgage payment is more than $1,000. So again, thinking about what that would look like on my graph, $1,000 is greater than the average of 982. And I want to be more than that, and it would be more than that on the number line to the right. Hopefully that's common sense to you. Numbers that are larger are always to the right. Numbers that are smaller are always to the left. So that helps me identify the fact that this particular scenario is a right tail. And again, the fact that I'm looking for the probability tells me that the area is defined by the X value. So out to Minitab, top menu bar, graph, probability distribution plot, arrow to the right highlighting view probability. The distribution is normal. The mean is 982. I'm going to double check. The standard deviation is 180. That was given to me in the scenario. My shaded area is defined by an X value, is a right tail, and it was $1,000. I click OK. Now you can't hardly see the X values on the horizontal. What you need, again, is this decimal number. And again, if you'll notice, this graph has a similar shape to the one that I drew. Okay, so the red shaded region is 0.4602. Okay, so the red shaded region is 0.4602. So the probability that a randomly selected monthly mortgage payment would be greater or more than $1,000 is about 46%. That's what that means. Okay. The probability a randomly selected monthly mortgage payment is more than $1,000 is 0.4602, or if I wrote it as a percentage, it would be about 46%. Okay, using the same scenario, average monthly mortgage payments are normally distributed, mean of 982, standard deviation of 180. What is the probability? And I want to change this problem. I'm going to show you how to do a less than. So I'm going to change the B to a less than. Is less than 1,475. Okay, so I've changed that problem. Again, if we think about the picture, okay, we know that we have a normal distribution. It tells us that our mortgage payments are normally distributed. Horizontal axis, bell-shaped curve, mean is in the middle of 982. It says, what's the probability that my mortgage payment is less than $1,475? Okay, so again, thinking about my graph, 1475 is going to be over here to the right, but I want to be less than that. So I'm actually looking for this big shaded region to the left. Less than would be to the left. So this is actually going to be a left tail test. Again, because I'm looking for the probability, and I'll emphasize it here for you, My shaded area is defined by the X value. So then I go out to Minitab. Top menu bar, graph, probability distribution plot, arrow to the right, view probability. It is a normal distribution. The mean is 982. The standard deviation is 180. I'm to the shaded area. Shaded area is defined by the X value. It is a left tail, and my X value is 1475. I click OK. And again, you get the graph. You can see the X value of 1475, and the red shaded region is to the left, and it's 0.9969. Okay, so according to Minitab, this red shaded region is 0.9969. So the probability that a randomly selected monthly mortgage payment is less than $1,475 is 0.9969, or roughly 100% if you round it. All right, same scenario, monthly mortgage payments, mean of 982, standard deviation of 180, and we want to know the probability that the mortgage payment is between 800 and 1150. Okay, so I have my horizontal axis, my bell-shaped curve, my mean is in the middle, which is 982. This one says between, okay, so if you're writing this in symbols, we're looking for the probability that 800 is greater than the mortgage, which is less than 1150. So I'm between 800 and 1150. Visually, 800 would be on the left, 1150 would be on the right, and I'm looking for the area between those two numbers. So I'm looking for this red shaded region here. In terms of whether it's a right tail, left tail, this one in Minitab is called the middle. Okay, it's called the middle. And again, we're looking for the probability, so our shaded area is defined by, again, the X value. In this scenario, however, you have two X values. You have 800 and you have 1150. So you're going to have an X sub 1 and an X sub 2. You have to enter both numbers because you have to tell it the beginning and you have to tell it the end. So I'm going out to Minitab, graph, probability distribution plot, arrow to the right, view probability, click OK. It is a normal distribution with a mean of 982, standard deviation of 180. The shaded area is defined by the X value, but this time I want the middle. My low X value is 800. My high is 1150. Always read the number line left to right. I click OK. Again, you get a picture similar to the one that I drew, and I get 0.6687. Okay, so the red shaded region, according to Minitab, is 0.6687. Okay. To the third scenario. Okay. Check your blood pressure. In a recent study, the Centers for Disease Control and Prevention in Atlanta reported that diastolic blood pressures of adult women in the United States are approximately normally distributed with a mean of 80.5 and a standard deviation of 9.9. Okay, so it's telling us that the diastolic blood pressures of women are normally distributed with a mean of 80.5 and a standard deviation of 9.9. You have to know those three things. Then it says, find the probability that a randomly selected woman will have a diastolic blood pressure lower than 70. So if I do me a rough sketch here, I have a horizontal axis, my bell-shaped curve with a mean of 80.5, and I want to know the probability that a woman's blood pressure is lower or less than 70. So thinking about my picture, okay, 70 would be on the left-hand side because it's less than 80.5, and I want to be lower or less than that. So I'm out here on the end on the left-hand side. So this would be considered a left tail. Because I'm looking for the probability, my shaded area is defined by the X value. So out to Minitab I go. Graph, probability distribution. Arrow to the right, view probability. Okay, it is a normal distribution. The mean is 80.5 and the standard deviation is 9.9. Shaded area defined by the X value. It's a left tail and it's 70. Click OK. I get 0.1444. So my red shaded region here is 0.1444. There's the answer. Okay, find the probability that a randomly selected woman will have a diastolic blood pressure between 75 and 90. Again, if you think about the graph, horizontal number line, bell-shaped distribution, mean is in the middle, which is 80.5. We want to know the probability that we're between 75 and 90. So visually, we have 75 on the left side and 90 on the right side, and we're between. The between in Minitab is a middle. Because I'm looking for the probability, my shaded area is defined by the X value or values in this case. So out to Minitab we go. Graph, probability distribution plot, view probability, Normal distribution, mean of 80.5, standard deviation of 9.9. My shaded area is defined by the x values for the middle, and I'm between 75 and 90. I click OK. I get 0.5421. So this red shaded region is 0.5421. Now, the next question might throw you off because it doesn't really say find a probability or find an x value. But guys, think about it. Is it unusual for a woman to have a diastolic blood pressure lower than 65? Notice this is an x value. It's not a percentage. And the idea of being unusual is related back to probability. So it really is asking you for the probability. Okay, so I have my bell-shaped distribution. The mean is in the middle, which is 80.5. We want to know the probability that she has a blood pressure lower or less than 65. Okay, so thinking about what that would look like, 65 would be on the left. If I want to be less than that, I'm going to be to the left. So this is considered a left tail. Again, I'm given an x value, so my shaded area is defined by the x value. Back to Minitab we go. Graph, probability distribution plot, arrow to view probability. It is a normal distribution with a mean of 80.5, standard deviation of 9.9. My shaded area is defined by the x value. I'm going to be in the left tail, and I'm interested in the value of 65. And I get 0.05871. Okay, so this red shaded region is 0.05871. So you're looking at about 6% of women would have a blood pressure lower than 65, diastolic blood pressure lower than 65. I would say that's unusual because 6% is reasonably close to zero. All right, letter D, same scenario. A diastolic blood pressure greater than 90 is classified as hypertension or high blood pressure. What percent of women have hypertension? So again, thinking about this, we have our horizontal axis, our bell-shaped curve, because we know that the blood pressures are normally distributed with a mean of 80.5 and a standard deviation of 9.9. And we want to know the probability that a woman has a diastolic blood pressure greater than 90, which would mean she has high blood pressure. So 90 would be to the right, and to be greater than that, you would be to the right. So this is a right tail test. Again, you start out with an x value, so your shaded area is defined by an x value. Minitab, graph, probability distribution plot, view probability. It's normal. Mean is 80.5. Standard deviation is 9.9. The shaded area is defined by an x value. It's a right tail. My x value is 90. Click OK. 0.1686. The red shaded region, according to Minitab, that probability is, as a decimal, 0.1686. Okay, remember that's a decimal. This question asks for it in terms of a percentage. So we would multiply the decimal times 100%, which gives us 16.86%, or about 17% of women have hypertension. Again, letter E, the phrasing of this question might be confusing to you because it says, what is the 75th percentile? Okay, they're actually asking you to find the value of the 75th percentile. Again, it's the wording, but we know that women's diastolic blood pressures are normally distributed. The mean is 80.5, and we're looking for the 75th percentile. Okay, a couple of things to remember. Remember that we start at the left, that goes 0 up to 100%. The mean, which is in the middle, remember, is the halfway point, or 50%. And that's important for you to know because we're looking for the 75th percentile. The way you interpret a percentile, we're saying that 75% of the data is below that value. So 75% is going to be somewhere over here, and it's going to be below that. So this would define the 75th percentile. Now 75% as a decimal is 0.75, and I want to know what that X value would be. So in this scenario, you're given the percentage to start with. So your shaded area is defined by probability. Okay, and we're doing 75% because it's important that you remember anytime you're dealing with percentiles, it's always the area to the left, or the percentage below. Okay, so I'm going to Minitab, graph, probability distribution plot, U probability, normal distribution, mean of 80.5, standard deviation of 9.9. My shaded area is defined by probability. It's to the left, and I'm doing 0.75. I click OK. Okay, so you can see it shows that I have 75%. The X value, which is on the horizontal axis, is 87.18. Okay, so my corresponding diastolic blood pressure for the 75th percentile is 87.18. Okay, I hope those examples, I didn't do the answers to the last ones. I'll add the answers on there for those of you who are going to use that document. But hopefully these examples will help you have a better understanding of how to use Minitab to solve the probability problems related to the normal distribution.